assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
In order to answer these questions, we have to be familiar with the reactions that occur between alkali metals and various nonmetals. Let's begin with A. In A, we see that cesium is reacting with water. Cesium is indeed an alkali metal. When alkali metals react with water, they yield a solution with the metal's cation plus a hydroxide anion and hydrogen gas. Knowing this, we can now fill out the rest of the equation so we can have the products. Given that our alkali metal is cesium, our cation is going to be cesium cation. And since cesium is a cation, it is able to dissolve in water, so it's aqueous. Next, we have the hydroxide anion, which is also aqueous. And finally, we have hydrogen, which is a gas. Now that we have our complete reaction, all we have to do is write out our coefficients. As we can see, we have 1 more mole of hydrogen on the product side than we do on the reactant side. Let's try to fix this by putting a 2 in front of our hydroxide. In order to balance the right side and the left side, we can also add a 2 in front of the water. So now let's check our coefficients to see if we have the correct molar ratio. Right now we have 1 cesium on each side. So cesium looks good. Now we can check hydrogen. We have 4 on each side, so that looks good also. And then we look at oxygen. We see that we have 2 oxygens on each side, so that looks good. The reaction is balanced. Let's move on to the next part of the question. The second part of the question shows that rubidium is going to react with oxygen. Recall that for the alkali metals, potassium, rubidium, and cesium, they are going to react differently with oxygen than the other alkali metals. So, when rubidium reacts with oxygen, we yield superoxide ionic compound. Knowing this, let's remind ourselves that the superoxide ion is equal to O2 with a -1 charge. So the superoxide ionic compound for this rubidium metal is going to yield rubidium with a charge of 1 and superoxide with a charge of -1. So that gives us a 1-to-1 ratio. Now we simply have to balance the equation, but the equation is actually already balanced. And we have to make sure that we include all of the phases. The superoxide is going to be a solid. So now we can move on to part 3. For the sake of saving space, I just wrote part 3 on a new page. So as we can see, what we have here is potassium, which is an alkali metal. reacting with ammonia. When an alkali metal reacts with ammonia, it's going to yield a cation that interacts with the amide ion, as well as hydrogen gas. Now that we have the general products, we can fill this in using potassium. So our cation is going to be potassium. And when we write the cations, we're just going to write that they're dissolved or soluble. The amide ion, as a reminder, is NH2 minus. And again, this is soluble. And finally, we have hydrogen gas. Now that we have our products, we can just balance our equation. So let's start by balancing the hydrogens. As we can see, we have 4 hydrogens on the right side and 3 hydrogens on the left. So we want to try to make the odd number into an even number. That makes it easier for us. So let's put a coefficient of 2 in front of ammonia. Now that we have 6 hydrogens on the left side and 4 on the right, we want to add 2 more hydrogens on the right side. We could do this by balancing, putting a 2 in front of the amide ion. This is going to balance not only our H's, giving us a total of 6 on both sides, but also our ammonia. In addition, we want to keep the number of electrons the same on both sides of the equation. So we want to make sure that we give potassium a coefficient of 2 as well, because we don't want to have too many electrons or too few electrons on either side of the equation. This is the balanced equation for part 3, and I'm just going to highlight it. And if you need a reminder for the answers for part A and B, I wrote it on the previous page.